Hello, my name is Steve Jamieson, and I'm going to talk to you today about Compensating Resource Managers. Compensating Resource Managers are a new feature of Com+ 1.0, which will be part of Windows 2000. So let's get on to the first question, which is what actually is a Compensating Resource Manager? I think it's worth just covering a little bit of terminology first, because there's a little bit of confusion about this. We are not actually shipping a CRM per se. What we're shipping is the CRM feature or infrastructure. We're kind of shipping a toolkit to allow users to develop CRMs themselves. A CRM itself is actually a type of resource manager, and like all resource managers, resource managers need to implement the traditional transactional ACID properties, which is atomicity, consistency, isolation, and durability. The CRM provides the atomicity, consistency, and durability parts of this for you, but it does not automatically provide the isolation part, which is very important, and I'll explain a little bit more about that later on. So it's basically an easier way to create a resource manager. So what do we mean by that? Those of you who remember Microsoft Transaction Server, in that product we had a software development kit where we allowed users to develop resource dispensers, and we had a resource dispenser development kit. And when you developed a resource dispenser in MTS, you had to figure out how to talk to DTC, how to handle callbacks from DTC, how to switch threads, how to pool your resources, and how to provide a logging mechanism to make your resource dispenser durable. So it was a fairly complex and difficult task. Now we still support resource dispensers in Com+ 1.0, but basically the CRM allows you a much easier option to build a simple resource manager. And why is that? Well, you develop the resource manager simply as a pair of Com+ components, a CRM worker and a CRM compensator. And the CRM infrastructure will provide the transaction outcome notifications to your CRM compensator. So it will provide the prepare notifications, and you can use that. You can vote from those, and it will also provide the commit and the abort notifications. We provide a durable log that you can use, and the threading issues are very much simplified because it's just basically Com+. The CRM itself doesn't do resource pooling, which was a feature of the resource dispenser, but you can use the Com+ object pooling feature with CRMs, so that's a combination of features to get you back to the same functionality you had with MTS. So, who do we think the users of the CRM will be? Well, there's certain classes of CRM users. Firstly, there's the CRM developers. They're the folks who develop a specific type of CRM for a specific type of task. Then there will be the Com+ application developers who will use that CRM in their application. And then there are Com+ administrators who will deploy these components as part of that application. And then there's the actual end users. And we think that they, most of the time they won't even know they're actually using the CRM. These are some of the applications that we think will be application areas that the CRM will be used for. In fact, we're using it ourselves internally in a thing called the RegDB CRM, which is actually part of Com+, and it's used for the admin inside our own system application. So we found a use for it in there. We think the major area will be the legacy applications, where you're trying to integrate or hook some other type of existing transactional system into the Com+ transactional programming model. We also think that there's some application areas in making non-traditional resource managers, such as making the file system transactional or the registry or trying to do email. But when you do that, you have to be very careful about the isolation issues, and I'll cover that a little bit later on. So here's a quick overview of the architecture of the CRM. You'll see in orange there, that's the application component that comes in, and the white is the parts that are developed by the CRM developer. They are the actual CRM. And the blue pieces and the TXF log at the bottom are the pieces that we provide as part of Com+. Now all of this architecture here, all of this picture is in one application server process. And the TXF log at the bottom has its own log file. So there's one log file per application server process. The other thing I should mention at this point is the CRM recovery is done when that application server process starts up. And I'll cover that in more detail later on. So this is a quick overview of the main interfaces used by the CRM. First of all, we have iCRM log control, which was on the architecture slide previously. This is used by the CRM worker, and it's implemented by a CRM clerk component, which is our internal component. And the CRM worker uses that interface to write the log records to a durable log. And we also provide that interface to the CRM compensator when we create it, so that it can write further records if desired. iCRM compensator, as its name implies, is implemented by the CRM compensator, and we use that to deliver the transaction outcome to the CRM compensator, to tell it what happened to the transaction. And we also deliver the log records that were written by the CRM worker to the CRM compensator as we deliver the transaction outcomes. The CRM compensator votes on the transaction using that interface, so it participates as a real RM. It can say, no, I can't prepare, and you need to roll back the transaction. We also have another type of this interface, another version, which is iCRM compensator variants, which is pretty much identical to the iCRM compensator, but it's slightly different in its record formats, and it's more optimized for VB and VJ components. So here's a quick bit more detail on the iCRM log control interface, and I'll just run briefly through the methods and what they do. We have a transaction unit of work method, which basically is a way to retrieve the transaction unit of work of the current transaction that you're in. We found this was quite useful because a lot of people are using that as a key to solve the isolation issues, and hopefully that will become a little bit more clear later on. And people were actually logging the transaction unit of work in the log records, which is kind of superfluous because we have it in there already, and this was just a way to quickly and easily get at it. Register compensator is the first method that the CRM worker would call, and basically what that method does is it tells us what compensator, what the prog ID, or we can look up the class ID from that, what compensator you want to use. And you can also provide a description string, which is used by our monitoring tools, and you can provide some flags to give us some options. Write log record variants is how you give us a log record and tell us to write that to the log. Force log is the method that makes those log records durable on disk. So write log record variants basically just caches the record. It says here's the record to write, but it doesn't actually force it to the disk. And this is a performance optimization. We have a method called forget log record, which is in case of errors. You can actually forget the log record that was written. This optimizes some of the recovery scenarios. We have a force transaction to abort method, which again which initiates an immediate abort on the transaction in case something goes wrong. And then we have write log record, which is the VC version of write log record variants. So the write log record variants and write log record are basically the same, except one is optimized for the VB and VJ case, and one is optimized for the VC case. And in the VC case, we basically provide the log record as an array of blobs of data, and we implement a gather interface there, which is pretty handy for building up log records made from typically a log record would have a header and some sections, so it avoids some copying there. So what happens in normal operation? I'll just walk through this briefly. This is kind of explaining what your CRM worker would need to do. First of all, the CRM worker would co-create instance of a CRM clerk to get the iCRM log control interface. Then it would register its compensator, which tells us which CRM compensator you're going to use when the transaction completes. Then you write the log records, and it's very important to notice here that you're doing write ahead. In other words, you must do the write and make it durable before you do any work. And this is very important because if you don't do this, if you did the work and then you crashed, we wouldn't know how to undo the work. So write ahead is a very important piece. Then you would force the record to the disk, and that would make it durable on disk, and then you would do the actual work required by the CRM worker. And at that point, the caller would do set complete or set abort, and the transaction would complete. So I'll just cover briefly the iSerum compensator, take a quick look at this, this interface, and you'll see that the first method here is set log control, which is the way we give the iSerum log control interface to the Serum compensator. And you'll also notice here that we have the begin prepare, prepare record, and end prepare, and begin commit, commit record, and end commit. We kind of bracket the phases, the prepare phase, the commit phase, and the abort phase. They're basically very similar. And each of those, in the prepare record method, for example, we provide the log record to the Serum compensator so that it can do its work. The other thing to note here is the end prepare method has an OK to prepare flag, which is the means by which the Serum compensator votes on the transaction outcome. And also there's the iSerum compensator variance interface, which is the VB or VJ version of this, is very similar. I won't cover that in too much detail. So once the transaction completes, the Serum compensator kicks into action. This is a component that implements the iSerum compensator interface, and it's created by the Serum infrastructure when the transaction completes. It gets the prepare notifications, and it can vote yes or no, and then it gets the commit or the abort notifications depending on what happened to the transaction. It receives the original log records with the notifications, and it uses those notifications plus the original log records to either roll back the work in the abort case or clean up the state in the commit case. Let me just clarify what that means. When your worker is doing its work, you need to, in the log record, you keep some state, but you also might need to keep some other state around in case you need to roll back. And the commit notifications are basically used to throw that state away because you no longer need it. And once this is done, those old log records are free to be discarded from the log. It doesn't necessarily mean that they are discarded from the log at this point, it just means that they are free to be discarded from the log. And when the CRM checkpoints kick in, they will clear out old stuff out of the log file. The other very important thing to note about the CRM compensator is that the work done in these notifications must be idempotent. That means that if you do it again, it must lead to the same result. So the typical example for an idempotent update is when you set a balance in a bank account. If you set a balance to a specific figure like $100, that's an idempotent action, because if you set it to $100 again, the value will still be $100. If, on the other hand, you were to increment it by $100, if you did that action again, the result will be different each time. So it's very important that you have idempotent actions for the CRM compensator. Just to give you some scenarios where that might be important, for example, if, as I discussed before in the write-ahead case, if you managed to write the log record but didn't actually do the work, you would get the log record in the transaction outcome notifications, but the work would not actually have been done. So your compensator needs to handle that case as well. And the other possibility is perhaps you were in the process of recovery and there was a crash, and the log records were still in the log, so you might get them again, and you'd be asked to abort the transaction again, in which case your CRM compensator would have to handle that situation. So let's walk through a specific example of a CRM compensator, and this is an example from our platform SDK in the ComPlus samples, and this is an example of a delete file CRM, a CRM that its function is to simply delete a file, and if the transaction commits, you want the file to be deleted, and if the transaction aborts, you want us to put the file back again. So what would the CRM worker do? It would implement a task-specific interface, let's say one method called delete file, and one parameter, which would be the name of the file that we want to delete. The worker would co-create instance on the CRM clerk, it would get the iCRM log control interface, and the first thing it would do is call register compensator to tell us the name of its compensator, which would be the delete file CRM compensator. So the worker would then write the original file name plus a temp file name to the log, and then it would force those to make them durable on disk. So we generate some temp file name and write these two parameters into our log. And then we would rename the original file to a temp file. And basically what we're doing here is we're keeping some state around, and the state is itself the file, renamed as a temp file, in case we need to go back and put it back. And then the transaction would complete. So at that point, the CRM infrastructure swings into action and creates the CRM compensator. And in this case, we know which compensator to create. It's the delete file CRM compensator. We then deliver to that CRM compensator the prepare notifications with the original log record, and that CRM compensator would vote yes. Note, in this case, it doesn't do any work. There's really nothing to do at this point. It can just vote yes, and that's the end of it. Now, if the transaction commits, the CRM compensator will then get the commit notification with the original log record, which contains the temp file name. So it knows that it needs to delete the temp file at this point. So that's the cleanup of state that I was talking about before. If the transaction aborts, the compensator gets the abort notification, and it basically renames the temp file back to the original name, and that's the rollback action. So we're back to where we started. So one thing this example clearly shows is the isolation issue, because the resource in this case, which is the file system, is actually visible to other users, and it's not locked during that transaction. So if we were to crash during that transaction before recovery is done, the file would appear to be deleted even though the transaction has not completed. Also, the client doesn't actually know when the transaction has completed. He says delete file, and it says OK. And at that point we know the prepare phase has been done, but we don't know for sure that the commit or the abort actions have been run. And no one must depend on the results of this transaction until it is truly completed. So the isolation issue is a very important one, and basically what we do in the CRM is we push that off to the application level and say, okay, the application needs to understand what it's doing with the CRMs and needs to solve the problem. So for example, in this issue, you'd have to be careful that only one client or one piece of the application, one thread, was trying to delete the same file at the same time, for example. We find this is it works better in those cases where you're hooking up to a transactional legacy system, because they typically have some transactional identifier and locking mechanism in place, which helps out enormously with these isolation questions. I'll briefly walk through the recovery issue, how recovery is done. As I mentioned before, each server application process has its own log file, and the recovery is done as that server application process starts up. First thing that happens is the CRM infrastructure finds the correct CRM log file based on the application ID for that application and begins recovery. It may need to contact DTC to find out what happened to some of these transactions if they get into an unknown state. And then the CRM infrastructure will create the CRM compensators it finds in its log file that have not completed their transactions, and it feeds them the log records. So the compensation process is very similar to described in the normal situation. And again, once this is done, those old log records are free to be checkpointed out of the log. I'll briefly cover how these CRMs are deployed. Well, basically they're just COM components. They're deployed exactly like any other COM+ component. They can be deployed in server or library applications. They can be exported or imported with the applications as usual. However, it's important to note that CRMs can only actually run in server applications because server applications have a log file. They have an identity, and so they must only run in server applications. That's the thing that does a recovery. And there's one little user interface option that needs to be checked, which is enable compensating resource managers on the UI, and that basically tells the server application that it needs to do a recovery when it starts up. This is just to discuss some practical matters about what settings you need on the components. CRM workers obviously require a transaction, and because of that they get sync and JIT. That's a requirement that's mandatory if they have a transaction. And they must not be main threaded, because that will lead to deadlocks. We recommend both threaded, but that cannot be used for VB, obviously. Likewise, for the CRM compensator, it's important to note that that does not have a transaction, and you're not running under a transaction at the time any of the CRM compensator methods are invoked. Again, it should not be main threaded, And there are some limitations on apartment-threaded components to avoid deadlocks, and those are documented in the online documentation. Just to cover a few more details about the serum log files and how we handle those. We default the location to be the same location as the DTC log file, which is normally your system directory under the DTC log directory. We have an override possible, so there is an API actually that you can override the serum log file path, and that's important in case you're operating on clusters. And I won't go into a great deal of detail about that, other than to say on clusters there are two types of CRMs. There's CRMs that care which node of the cluster they're running on, and the CRMs that don't care which node of the cluster they're running on. And so it's very important to decide in that case where your log file needs to be. The log file name is of the form as shown on the slide there. It's basically the app ID of the application server process with a CRM log extension. There is some security concern because when your serum log file could conceivably have some sensitive information in there because of the types of records you're logging. And so we do implement security on the serum log file when we create it, and only under those two specific cases: if you're running on the NTFS file system and if you're running as a specific user identity in your application server process. So if it's interactive user, we don't put any security on there. We default the size to 1 meg, and we extend that serum log file as required. So we've tried to be as zero admin as possible. The CRM also has a set of monitoring interfaces, which are basically, I'll only touch on this briefly, but they can be used by monitoring tools for viewing the state of transactions and really digging down into the log records and finding out what's going on. We see those being used for sort of fault-finding situations, etc. And those monitoring interfaces are only available in process with the CRM of interest. So you have to get a component inside that application before you can access these monitoring interfaces. And there's a quick overview of those on that slide there. I won't cover those in detail because I'll just go through this, how they might be used. So in that application server process that you want to monitor, you have to figure out a way to find that. You'd co-create instance on the CRM recovery clerk, which is a singleton component. There's only one of them in that application server process, and you get this iCRM monitor interface. You then call that to get another object, which we call the clerks collection object, which basically gives you a snapshot of the state of the CRM clerks, because clerks may be coming and going as the CRMs are active. So you get a snapshot at a moment in time. And what you use that snapshot to search through and find, say, the transaction you want, or the activity ID, or the description of the CRM of the transaction. And you then say, hold that specific clerk, and then you'll get an interface on that clerk which allows you to drill down and look at specific log records. And we don't do monitoring during recovery. We have another feature called recovery trace, which you can turn on via registry flags, which will dump out some information and help sort out the recovery. So there's the interface. There's the email address if you have any questions. And just like to note also that the platform SDK has the CRM samples on there.